Earthquakes, when the earth shakes. B1 level listening text. Introduction. The invisible monster. Welcome to this audio story. We live on what seems like solid ground. We build our homes, our schools, and our cities on it. But sometimes the very ground beneath our feet moves. It shakes, it cracks, and it destroys. This is an earthquake. For most of human history, earthquakes were terrifying mysteries. People thought they were punishments from angry gods or movements of a giant monster living underground. Today, thanks to science and reason, we know the true, amazing story behind why the earth shakes. It is a story not of monsters, but of giant puzzle pieces constantly on the move. Part 1. The giant puzzle pieces. To understand earthquakes, we must first look deep inside the earth. The earth is not one solid piece of rock, like a bowling ball. It is structured more like a giant, boiled egg. It is a thin shell, a hot, soft middle, and a solid center. The thin shell is called the crust, and it is cracked into giant pieces. Scientists call these pieces tectonic plates. Imagine a giant jigsaw puzzle covering the whole world. There are about 15 major plates, and they float very slowly on the hot, melted rock beneath them. These plates are always on the move. They drift only a few centimeters every year, about as fast as your fingernails grow. But they are giant and heavy, so even this small movement creates immense force. Part 2. The 3 types of movement. When these giant plates meet, they don't just gently slide past each other. They interact in 3 main ways, and each interaction can cause an earthquake. First, plates can diverge, meaning they pull apart. This usually happens on the ocean floor, when new ground is created as magma rises. Small earthquakes happen here as the crust stretches. Second, plates can converge, meaning they crash together. When an ocean plate hits a continental plate, the ocean plate is often forced down into the hot middle. This creates deep, powerful earthquakes and can build mountains like the Himalayas. Third, plates can slide past each other. They try to slide, but they are rough and they get stuck. They push and push for years, and the tension builds up like a stretched rubber band. When the force becomes too great, they suddenly snap loose and slide. That sudden snap is an earthquake. The location on the ground directly above where the plate snap is called an epicenter. Part 3. Measuring the monster. Scientists who study earthquakes are called seismologists. They use a special instrument called a seismometer to measure the shakes. When an earthquake happens, the seismometer draws zigzag lines on paper or computer screen. The larger the zigzags, the stronger the earthquake. To describe the power of an earthquake, scientists use a magnitude scale. You might have heard magnitude 5 or magnitude 8. A magnitude 5 is a moderate earthquake. Things might fall off shelves. But a magnitude 8 or higher is a great earthquake, which can cause massive destruction. Part 4. A story of tragedy. The Lisbon earthquake, 1755. Now, let's travel back to a time just before the Aden Lamakagi truly spread, November 1st, 1755. It was All Saints' Day in Lisbon, Portugal. Most people were inside beautiful churches. Suddenly, a massive earthquake, estimated at magnitude 8.5 to 9, struck. The city shook for several minutes. Beautiful churches collapsed, killing thousands. But the tragedy was not over. 40 minutes after the shaking, a giant wall of water, a tsunami, raced into the harbor, drowning many who were escaping. And if that wasn't enough, fires broke out all over the city and burned for 5 days. 80,000 people died. The Lisbon earthquake was a shocking tragedy that made philosophers like Voltaire question old beliefs. They realized that society must stop just praying and start using reason to build stronger, safer cities and study natural disasters scientifically. Part 5. More great earthquakes in history. Lisbon is just one story. History is full of great shakes. Valdivia, Chile, 1960, the strongest earthquake ever recorded, with a massive magnitude of 9.5. It triggered tsunamis that crossed the entire Pacific Ocean, hitting Hawaii and Japan. Indian Ocean, 2004, a powerful magnitude 9.1 earthquake on the ocean floor caused a devastating tsunami. It hit 14 countries, including Indonesia and Thailand, and killed over 230,000 people. It was a modern reminder of nature's power. Tohoku, Japan, 2011, a magnitude 9.0 earthquake off the coast of Japan. It was so powerful it actually moved the main island of Japan and shifted the Earth's axis. The resulting tsunami caused a major nuclear accident at the Fukushima power plant. Conclusion: living with a giant puzzle. We cannot stop the tectonic plates from moving. We cannot prevent earthquakes. They are a natural, necessary part of our planet. They shape mountains, create oceans, and prove that Earth is alive and active. However, we can use the light of reason to adapt and survive. Today, we have building codes to make structures that shake but do not collapse. We have early warning systems to give people seconds to prepare. We educate citizens on what to do during a shake: drop, cover, and hold on. The story of earthquakes is a story of human courage against immense natural forces. By understanding the Yorulti puzzle pieces, we stop fearing a monster and start building a safer future on our shaky, beautiful world.